it. So this is basically Excel based tool that you must be able to understand. The first one is serial number, the second one is the location, that is main location, then that is sub location, that is feeder name, and then we give us a image number, wherein you can refer what is exactly happening on the thermal image, and then point of concern that we mention. So maybe which phase is is basically overheating. Then hotspot, on that particular phase, what is the hotspot, that is what is the maximum temperature that has been seen. Then related cool spot. So now this is more interesting to understand. Like if you got the three phases and neutral flowing, and so everywhere the current is flowing, okay, and at particular phase you see a overheating, and other two phases seems to be normal. So what do we mean by related cool spot is when everything is normal. So what is the temperature that is cable is going to subject to? So maybe let's say here in this case, let's say 46 or something, what you see. Okay. Okay. Then what is the current that is flowing through that we, so from here to this till S, this is the complete tool. So that tool, these are the hidden cells. So that needs that is actually some big calculations that we have to make. Uh, Again, as I said, what we have to write is the current that is flowing, then the breaker size. Depending on the breaker size, uh, here if you see, depending upon the breaker size, the contact resistance will change. Now this is the ambient room temperature. That this value also you have to enter manually. Then this is all now formula based, so don't you don't require to do anything with this. So contact resistance in micro ohm. So suppose this is not again a very anywhere written in the standard that the breaker of 200 ampere, 1 to 200 ampere will only have a 40 micro ohm as a contact resistance. This is just a practice that we follow, and there is no such a standard or anything mentioned anywhere. Uh, so okay, we'll go ahead. Now then, expected temperature on a conductor. So now if you see 63 ampere is flowing, breaker size is 200 ampere. That means the contact resistance, ideal contact resistance should be a 40 micro ohm, and the room temperature is 30. Then what is the expected temperature of the conductor will be having? So the conductor will be having 30.8. So zero point 0.8 is the rise over ambient. Okay, but now here you have seen a 91 degree centigrade. So what does that mean? Either the 61, the difference is 61 degree. So what is the what does that indicate? uh, there are two possible things. One is you have a high contact resistance, that is something is wrong, loose connection or something is wrong, or you have a possible ambient temperature of 91 degree centigrade. Now what we can do is I can write 2963 as a contact resistance here, 2963. So that, then this says, yeah, right, if that is the contact resistance and 63 ampere is flowing, then you will expect a temperature of 91, and here is a 91. Okay, but this cannot be the case. Sorry. This can be the case. So basic culprit is the contact resistance, that is loose connection that you have. The another thing is that it is saying the possible ambient temperature is 91 degree. So 91 degree, that I'll explain in the next case with this. So you are now clear with this. So what is ambient temperature? What is contact resistance? This is a contact resistance that we expect could be the contact resistance. Then expected temperature on conductor, that is this. Then temperature difference. What is the difference from what is expected and what is practically observed? Then these two things explains you either the contact resistance is the culprit or the possible ambient ambient temperature is culprit. So above 40, if the ambient temperature goes above 40, that it automatically comes in a red, because it is hardly possible that the ambient temperature crosses 40 degree. So that we have mentioned. So the culprit becomes then contact resistance, and everything is done right, perfectly right. The contact resistance is not only the DC resistance that we are talking about, it's also the AC resistance that may be a problem for harmonic content. Now I'll show you what exactly we are trying to be the best on this. I will show you the one image and we'll then compare with this. Now see here the second one that we are trying to tell you here is, see, this is the main panel and this is a transformer incomer, and this is having a temperature spot 95 degree, but here the spot is 105, you can see 104.8, and that is a hot spot. Okay, and then related cool spot that we have taken as it's 55.3. 55.3 is because of this, because this is a neutral conductor and that might not having any current passing through it. So if on this conductor the temperature seen is 55, so basically we can consider this as a cooler spot, or this we can consider as a ambient temperature that exists on this compartment. Now let's see. Here is the stuff. Now I'm saying the conductor current that is flowing through this is 654 in all these bus bar and then breaker contacts, everything. And what we expect is 40 degree ambient we expect. And if we expect a 40 degree ambient, then the temperature, expected temperature on the conductor is 51. Got it? Got at the point? But now and the temperature is 51 here, that is expected. So 55, that is what we have seen on a neutral conductor. So on a neutral conductor there is no actually no current, so that doesn't any gives any idea that expected temperature matches with the related cooler temperature. But what we have to take the temperature is on this conductor, other conductors. So other conductors is also very high, that is 65, 64. This B phase is 74, a little hotter, and this is 55, that we now can consider this can be the ambient or a room temperature in this compartment, that what we can consider. So let's see what happens in this scenario. So as I put now here with this situation, what seen as a culprit is basically a possible temperature, ambient temperature of 83 to get 95 degrees centigrade. This is highly impossible. The second one is the contact resistance is 24. The expected is 5 and this is 24. Again, this we can expect this to be right. Okay. Now let's see what we can do here is we can do this stuff. We can let's say 55 is the ambient that exists. Now 55 is the ambient that exists. Then 66 is what the temperature in the conductor which is expected if everything goes right. So everything is right, and for if you see on the Y phase the current sorry, the temperature is 64, 65, 60, so that is perfectly okay. On B phase if you see it is 52 and then 72 and 73, 66, so that is perfectly okay. So here the ambient is a culprit for other phases, like for Y and B phases the temperature is 66 because the ambient seems to be in the range of 55. But obviously for this temperature of R is absolutely not as acceptable. So there is certainly the problem is with contact resistance. So I think the lug is not crimped properly on that particular things. So use grease, conducting grease into the lug and on the surface, so wherein the contact resistance can be minimized. I hope this tool is basically considered as a basic tool, and this certainly will help you find out what is going wrong. So here on this particular stuff we are stopping, and I think I can just show you this case as well, what is expected and what is we have observed. So let's quickly see into this. This is, I think, okay, and this, let's quickly check into this graph. Sorry, yeah, not okay. So this is basically the breaker that we have observed. Now here if you see, I'll just give a hot spot. This is 91.9 degrees centigrade. This is too hot, and the related temperature, cooler temperature, you can say 29, and then this is 22, this is 22, this is 22 and 23, 40. Again, this consisting of imbalance current and all this stuff. So here basically, if you, the picture is not very much clear, but the idea was, we have seen it, there was a very loose connection exists now. Because of the loose connection, the arcing that is formed, now it has corroded. Now the corrosion has taken place. So that is what is there on this. uh, I think now everything is clear to you. Here the busbar connection is improper, that what we have suggested. Not only okay, and this again, this factor still remains uh, not talked about it. So we'll talk about this now. Let's say 63 ampere is what the current is flowing through that bus bar, and we say the contact resistance to be in the range of this 2963 or something. uh, okay, so now this is basically the wattage that you can see that is getting wasted, or that is converted into heat. So the simple I square R losses that we are trying to say here. So 11 watt is continuously dissipated in the form of heat. So there is a loss of 11 watt on that particular contact every time that loss is happening. Okay, bye for the time being now, and we'll come up with the other thermal scanning videos on our consecutive series of thermal scanning. Thank you very much.